In this podcast, we're going to talk about Ionic Lewis Dot Structures. So first, let's look at the first problem. Okay, we have sodium and bromine. Which one's going to be the cation? Sodium is going to be the cation because he's positive, and he has a 1+ charge. And bromine's going to be the anion, and he's going to have a 1- charge. When we get to our formula, we're going to swap and drop our charges, and we're going to end up with NaBr. Okay, now it wants to talk about valence electrons. Well, valence electrons are the outer shell of electrons in an atom, and there's an easy way to tell it from our periodic table. So here is a rendition of our periodic table from our classroom. Try to take out some of the red so we could see the numbers really well. All right, see these numbers at the top? They're going to help us find valence electrons. So in this whole column, we have 1 valence electron for every atom in that column. The second one, we have 2 valence electrons for every atom in this column. We're going to omit the middle, as we usually do, because they don't really have rules. All right, and that takes us over to 13 through 18. All right, we're just going to forget that there's a 1 in front of all these, and we're just going to look at the number behind the 1. So this column has 3, this column has 4, this column has 5, this column has 6, 7, and 8. Okay? And in chemistry, everybody wants to be like this last row right here. They want to be like the noble gases. These are called the noble gases. So they want 8 valence electrons. So that's the whole reason that atoms form bonds. So let's go back to our original over here. All right, so number of valence electrons for the cation. Well, if you look, sodium's in the first column, so he's got 1 valence electron. And bromine, he's in column 17, but we just drop off the 1, so he has 7. Okay? All right, now we're going to draw the electrons around the symbols like little dots. Okay, so sodium has 1 valence electron, so there's that one. And then bromine has 7. All right, when you have several of them, I pretend there's a box around the symbol, and I give each side of the box an electron before I give anybody a pair. Okay? All right, so there's our 7. All right, now we know that everybody wants 8 valence electrons, so would it be easier for sodium to gain 7 or for bromine to gain 1? Be easier for bromine to gain 1. So this electron is going to transfer to the bromine, and that's all you have to write. Here's a little hint. Cations always give. Okay, so the metal, the first one, the positive one, is always going to be the giver, and the nonmetal is always going to be the taker. And that's all we're doing here. We're just showing where the electrons transfer. So let's look at the next set of aluminum and iodine. Aluminum is going to be our cation. He has a 3+ charge. Iodine is going to be our anion. He's got a 1- charge. When we get our formula, swap and drop, we're going to have Al I3. All right, now let's go to valence electrons. Al, this column, they have 3. And then I, he's in column 17, so he has 7. So 3 and 7. All right, now here's where it's a little different. You have to draw 1 aluminum, because that's how many we have in our formula, and 3 iodines, because that's how many we have in our formula. Okay, so we're going to have the 1 Al. He's got 3 valence electrons. All right, and then we're going to have to draw 3 I's. And they each have 7 valence electrons. All right, there we go. All right, so we know that our cations are our givers. Okay, so they're going to give these electrons, these 3 electrons, and we know that each of these iodines is lacking 1 electron to be that magic number of 8. Okay, so each of these is going to go like so. So aluminum will give 1 of its valence electrons to each iodine. Okay, so now these all have 8. And everybody's happy. All right, let's look at the last example. Magnesium and nitrogen. All right, magnesium is going to be our cation. He has a 2+ charge. Nitrogen is going to be our anion. He has a 3- charge. Swap and drop to get your formula. You get Mg3N2. All right, valence electrons. Magnesium right here, he has 2. And nitrogen has 5. Okay, so we have 2 and 5. All right, we're going to draw 3 magnesiums. 1, 2 valence electrons on each of them. Oops, that kind of looked like a pigtail or something. All right, and our last one. There we go. All right, and then we're going to draw 2 nitrogens. Okay, and they're each going to have 5. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. All right, now we just want to show where they go. Okay, all right, so magnesium is going to be the giver, and each nitrogen needs 3. So we're going to go here and there. All right, and he still needs 1 more, so we're going to have to take from the second magnesium. Okay, and then this one needs 3 as well. So we got 1, 2, and 3. And that's it. That's all there is to it. You're just showing where the electrons are transferred, because in ionic bonds, electrons get transferred between atoms. And that's it.